Hi. First of all, thank you to be present at this presentation. I will talk to you about transfer of pollutants from an old urban landfill and especially on physical and chemical characterization of waste, landfill leachate and groundwater. These researches were performed at IFTA, a French Institute of Science and Technology of Transport, Development and Networks, in collaboration with two other French laboratories. And this study constitutes the first part of my PhD works in collaboration with Béatrice Béchet, Cécile Le Guern, Laurent Sabater, and Hervé Andrieux. This presentation is divided into four parts. The first part develops the context of the site, and I will develop geologic and hydrogeologic system and landfill characteristic. The purpose of the second part is waste characterization. And the third part focused on groundwater pollution and the fate of organic and trace element components. And the fourth part constitutes the conclusion of this presentation. To begin, the landfill of Prairie-Mauve is located in west of France, in the city of Nantes, as seen in this map. And this site is not equipped with liner, is not equipped with collection system for leachate to prohibit the spreading in groundwater. Groundwater were studying in several boreholes around the landfill. And in this site, 6 to 8 meters of household and industrial waste were deposited between 1961 and 1987. And these wastes were deposited directly on alternating vases and clay associating with sandy gravelly level. And we found 3 aquifers. The first one installed in the embankments around the landfill, but also in the waste layer. This aquifer is partially connected to a second aquifer constituted by alluvial deposits. And the third aquifer was installed in micaschistous fractious rock. The aim of this study was to define the source of pollution, to assess groundwater quality, in order to study the transfer of pollutants from this landfill. Many investigations were performed in this site. Excavation well with a shovel, core drilling were performed to collect solid sample. Each solid sample were characterized and homogenized directly on site, and leachate sample were collected from seepage in waste layer. Another part of this work was to characterize groundwater pollution. Many piezometer and well in the vicinity of the landfill were studying, and series filtration were performed to define physical speciation of pollutants and identify landfill leachate and groundwater pollution. The waste collected in this landfill correspond to a set of household waste, and it contained mainly plastic, ferrous and aluminium container, chemicals, batteries, and pharmaceutical product care, associating also with rubbers. And 3 types of solid sample were studying. The first one is constituted by waste layer, in gray in this graph. Another one in white corresponds to interlayer level installed between the waste layer, and the suspended particle in the leachate sample. As seen in this graph, high concentration of trace elements were observed in this sample. However, very high concentration of arsenic, copper, and lead were observed in interlayer level, and very high concentration of zinc and chromium were observed in suspended particles. Apart polycyclic aromatic hydrocarbon, only pH and monoaromatic hydrocarbon were detected in these solids. And pH constitutes the most significant pollution in this layer. From pollution in leachate point of view, there is a limited pollution of trace elements represented by nickel and arsenic, but arsenic may come from a geochemical background. Indeed, the interior level installed in the landfill may be constituted by alteration of micaschistous rock, in which arsenic is present, and oxygenated rainfall may destabilize minerals present in this level and liberate arsenic in leachate in the landfill. From a xenobiotic compounds point of view, pH and PCBs were detected in this leachate, but no halogenated and no monoaromatic hydrocarbon were detected, contrary to the literature. The range of value observed in groundwater sample show high degradation of groundwater quality from up to downstream of the landfill, and these data are the same order than this in the literature. And high concentration of some ions, such as ammonium, are observed in groundwater. Concentration of ammonium, for example, exceeded the threshold level at which groundwater is considered as not suitable for drinking water production, according to French drinking water production. And a limited contamination of nickel and arsenic were observed. It must keep in mind that arsenic may come from a geochemical background. Perform filtration in different samples have shown the behavior of trace element in groundwater. For example, nickel is present, is not affected by filtration, so it is present in dissolved fraction, whereas copper and arsenic and chrome are present in dissolved and in particulate fraction. And to finish, iron, cadmium, and zinc are present high or total particulate behavior. The same trend were observed between arsenic and iron. The affinity of arsenic for oxyhydroxide of iron is well known. So iron should play a role to the fate of arsenic in groundwater. Variable concentration of pH and PCBs were observed in groundwater sample. And, for example, pH detected in groundwater correspond to this detected in leachate and in waste layer. To finish this presentation, the alluvial deposit correspond to alternating of sandy and clay silt, and analyzed with derricks show quartz, plagioclase, potassium feldspar, and group of clay detected, such as elite, vermiculite, smectite, and kaolinite. And further investigation are needed. And we want to localize heavy metal in oxide by micro-X fluorescence. To conclude this presentation, the waste layer show high concentration of trace elements such as nickel, arsenic, lead, or copper, and high concentration of pH and PCBs mainly. Leachate's quality show trace elements and soluble pH and PCBs were present, but no halogenated and no monoaromatic hydrocarbon were detected in this leachate. Suspended particles and in the leachate sample and interlayer level show high concentration of trace element, and a migration from waste to interlayer level was shown. Groundwater pollution show degradation between up to downstream of the landfill, and a very limited contamination of nickel and arsenic was observed, but a geochemical background exists on this site related to micaschistous rock. And this study shows the behavior of trace element in groundwater. So nickel is present in disulfration. Zinc, copper, arsenic, and chromium are present in particulate and disulfration, whereas cadmium, lead, and iron are present high or total particulate behavior. The absorption-disruption of arsenic in iron oxyhydroxide play a role in the arsenic fate. And the third conclusion, temporal variation of organic pollutants are observed in groundwater. Thank you for your attention.